Hi, welcome back to our video lecture. So for example, we need to evaluate the tangent cube x secant cube x dx. So we have this combination of function tangent and secant, both raised to 3. So as you can see here, this is under type 1 since both our m and n are both positive odd integers, so it is under type 1. Okay, so the first thing we're gonna do is we will kind of isolate the tangent and secant, the tangent and secant dx, because this will serve as the derivative of the secant. Okay, as we remember that in our calculus 1 we say that the derivative of our secant is equal to, or can be expressed as, tangent secant, or secant tangent, secant x tangent x dx. Okay, so remember we say that the derivative of the secant x is just secant x tangent x dx. So we're gonna isolate this this term here. That is our technique. So we're gonna isolate, sorry, secant x tangent x dx. So after isolating this term, let's now analyze our integrand and write what has been left in our integrand. So when we isolate this, what we have left here is tangent square x and secant square x. Okay, so let's check. Tangent square times tangent x, we have tangent cube x, and then secant square x, we have here secant x, we have secant cube x. So this main equation here is similar to this term. Okay, so after that we can now use the trigonometric identities regarding the tangent square x. So remember our trigonometric identities regarding tangent square x is just, it is equal to secant square x minus 1. So our tangent square x is just equal to secant square x minus 1. So substituting the value of tangent square x, we have the secant square x minus 1, then this is the tangent square x, then multiplied by the secant square x, then this term. Okay, so after that we can now simplify this by applying or by distributing this secant square to this term. Okay, so when we do that, this integrand will become secant squared x times secant squared x. So we have secant 4x minus this term secant square x, and then we have the secant x tangent x dx. Then after that, we can do the integration of various functions by distributing once again this term to the secant 4x minus secant squared x. Okay, therefore our integrand now became secant 4x multiply to this secant x tangent x dx, then minus the whole term of secant square x times the secant x tangent x dx. So we do that in order for us to come up and to follow the form of the power formula, because as we say that this is the derivative of this term and this is also the derivative of this term, but this term is raised to some power and also this term is raised to some power. So let us rewrite this as the secant x to the fourth power, and the derivative of this term here is this one. So we have the secant x tangent x dx minus, we do exactly the same process. We have secant x squared, then our derivative. Okay, so from here we can now use the change of variables. So we let q as equal to secant x, and then once again we say that the derivative of our secant x is just this term. Okay, we have secant x tangent x g of x. So substituting those variables through our integrand, so we have the secant x is just equal to u, so we have u raised to 4, and this term here is the secant x tangent x, the x is just our du, so we have u to the 4 du, then minus this integrand here, so we have this secant x which is equal to once again u, this is equal to u, but it is raised to 2, and then this whole term here secant x tangent x dx is just equal to our du. So from here we can now simply use our power formula. So according to our power formula, u raised to 4 plus 1, we have u to the 5 all over 5 in 10 minus u squared is u cubed all over 3. Do not forget to divide the this term by the new power, and then do not forget d plus c. This is now our indefinite integral, but again we need to bring back the value of our u, which is equal to secant x. So our u is equal to secant x, so u secant x raised to 5 all over 5 minus u once again, which is equal to secant x raised to 3 all over 3 plus c. Therefore the integral of tangent cube x secant cube x dx is just equal to secant x raised to 5 all over 5 minus x secant x cubed raised to 3 plus c. Or we can rewrite this as 1 over 5 secant 5x minus 1/3 secant 3x plus c. Once again, let us review. So we say that we have this problem, tangent cube x, secant cube x dx. Then this is a combined function involving tangent and secant. So we can use this trigonometric identity, but according to the combination of combined functions, we have 4 types. So if this m and n here are both positive odd integers, so we are under type 1, and our technique is just we imagine that the derivative of one of the function secant is just the combination of these two combined functions here. So we have the derivative of secant x is just the secant x tangent x. So we isolate this secant x tangent x so that we can use this later on as the derivative of secant x. Then after that, we do the algebra, and we say that the remaining values of tangent is tangent square x, because we have tangent raised to x raised to 1 there. So 2 plus 1 is 3. Okay, so the same thing with the secant square x and secant x here. Then right after that, we choose the trigonometric identity of tangent square x, this one, the tangent square x, which is equal to secant square x minus 1, in order for us to reduce our form into a purely secant what you call this, to a secant thing, so that we can use this secant with our plan, which is equal to the secant x tangent x dx there. Because when we distribute this secant square x to our converted trigonometric identity, is we can now get the secant to the 4th power x minus secant square x. Okay, then multiply by its derivative. So from there we can see that we can now use the power formula, because this term here is raised to 4, is the derivative of this is just this one. That's why we can now convert this into other variables. So we can easily see that it is already in the form of power formula. Okay, so we have u to the 4 du, then minus the integral of u squared du, and then from that we use the power formula and come up with this one. Then we bring back the value of u, which is secant x, and then we simplify our answer, or simplify our integrand, and come up with this answer. Okay, so that's all for this video. See you next time.